Let's integrate the square root of 1 plus y over 1 minus y with respect to y. The first thing I'm going to do in this problem is rewrite it so that I'm taking the square root of the top and the square root of the bottom. After that, I'm going to use an old fraction trick. I'm going to multiply the top and bottom by the same thing. And what I'm going to choose is not the complex, but the conjugate of the bottom. So instead of 1 minus y, 1 plus y. And the reason I'm going to do that is because it does something nice on the bottom. When I multiply 1 minus y and 1 plus y, I'm going to get a 1 minus y squared. Because both are under a square root, it'll be a square root of 1 minus y squared. And I know some antiderivative formulas that involve that expression. On the top, maybe even nicer, the square root of 1 plus y times the square root of 1 plus y is just, well, 1 plus y. So now I'm going to split this definite integral up into two parts, dividing both of the things on top by what's on the bottom. So over here, I actually recognize that as being the formula for when I take the antiderivative to give me inverse sine. Didn't say that particularly well, but it's one of the formulas we know. On this one, I'm actually going to go about it using a u substitution. See a y squared here and its derivative, or a function involving its derivative, y on top. So I'm going to imagine letting x equal 1 minus y squared, and then dx would be equal to minus 2y dy. So we're going to make that substitution. I'll have that y just hanging out on top for a moment. On the bottom, I have the square root of x, and that dy would become dx over minus 2y. The y's cancel. I'm going to rewrite that square root of x on the bottom as a x to the minus 1/2 dx. I have a minus 1/2 here I'm going to write out front. And now I'm ready to take an antiderivative. So I have the sine inverse of y minus 1/2 times, and let's see, add 1 to that exponent, you'll get 1/2. Divide by that 1/2, you'll get a 2, plus an arbitrary constant. I have sine inverse of y minus 2 times 1/2, just 1x to the 1/2, square root of x, and x was 1 minus y squared. And of course that plus c. And so there is our integral.